No, not yet. Okay, so these are the core outline of today's topic, that cloud computing technologies, the architecture. Although we have seen in our previous slide that NIST's cloud computing reference model, remember that that was also part of your one of your question, that there are 5 components that we have seen, but also we'll see some other uh, basic architecture that we can see for cloud computing. Then cloud computing infrastructures we are going to look into, and followed by 3 cloud computing system providing a system like Google, Amazon, and Microsoft's. So these are to cover today. Cloud computing technologies. There are actually there are a number of technologies that actually work behind the cloud computing platform to make it flexible, reliable, and usable. And these computing technologies could be named as virtualization, the most prominent one that also we have seen earlier. So virtualization, it makes our cloud computing that much of prominent that we see today. Another is service-oriented architecture, SOA, service-oriented architecture. We'll see. Then the grid computing, and there is another one is similar to grid computing, is a cluster computing. I don't know whether you have heard the name cluster computing, but very similar to what grid computing is. And another is the utility computing. So technologies that we are going to see, I mean, virtualization. I think we have seen a little bit earlier as well. Virtualization, actually, you see the figure over there, over here, that gives the concept of virtualization. Okay, that gives the concept of virtualization. We have user 1, user 2, user 3, actually, and there are a dedicated system for each user, and this system is called virtual machines. Actually, these are built upon, these are built upon a single hardware structure. So what virtualization is? Virtualization, it allows to share a single physical instance of an application or source among multiple organizations. That is customer. Okay, so you have a single physical instance. Okay. For example, hardwares that lie inside your server. Okay, so that can be shared to multiple or that can be served to multiple user or multiple organization. How does it do? Okay, it does this by assigning a logical name to a physical resource and provide a pointer to that physical resource when demanded. So this is your resource. So point, you give logical name and then assign those names to different users. So this is how it does. This is what we can see. Then the second second technology is service-oriented architecture. Service-oriented architecture. So virtualization. The first one is the virtualization. You have single instance, and you actually serve those single instance to multiple users. Service-oriented architecture. This allows to use applications as a service for other applications. So let's say that in your cloud environment, so this is your cloud environment, okay, that you have multiple applications, map services, locator services, and so on, for example. And uh, then so you are providing the services to multiple applications, even a single applications can access to, can get access to multiple uh, applications. So this application as a kind of service oriented architecture. So service oriented architecture. So this is applications as a service, as we say. Okay, applications as a service. So it allows exchange of the data between various applications. And that one. There are two different roles here. Service consumer request a service, okay, and then service provider, of course, they provide that service or response to that service. So the first point that we have seen, the technology is virtualization, right? And the second technology that we have just seen is service-oriented architecture. Service-oriented architecture. So the third one is grid computing. Third one is grid computing. Also, this also refers to distributed computing. This also refers to distributed computing. Also refers to distributed computing. So a group of computers from multiple locations, group of computer. They are geographically dispersed, geographically located in different places, and they are heterogeneous. Something like these ones. Database, this is supercomputer, laptops, maybe PCs, some other storage, maybe somewhere, storage, okay, and so on. So a group of computers from multiple locations are connected with each other. A group of computers from multiple locations, they are connected with each other to form the grid, And these computer resources are heterogeneous and geographically dispersed. Heterogeneous. They don't usually they serve different things. Okay, heterogeneous. They are not. I mean, not all are the similar one. So remember that just now I was mentioning about another is cluster computing. Cluster computing. So the basic difference between grid and cluster is that in grid actually it's heterogeneous, but cluster actually similar type of work, similar type of the computers or the devices or the resources, and the similar concept of geographically dispersed but similar type of resources. The computing resources are similar in cluster computing, okay, but in grid actually these computing resources are heterogeneous and geographically dispersed. So grid computing breaks complex tasks into smaller pieces. Grid computing breaks complex tasks into smaller pieces, which are distributed to CPUs that reside within the grid. You have a large task, so that task actually is divided into smaller piece and then given to different computers to solve. Okay, maybe there is another one here. Okay, and then Once the job are done, actually, then they are collected and it is served. So here, actually, in this model or in this grid computing technology, at least one computer works as a server within the grid. Okay. That's how the server actually does that part. So breaks complex tasks into smaller pieces, which are distributed to CPUs that receive within the grid. So what we have seen just now, three technologies. The first one is virtualization, right? Virtualization. Okay. The second one is SOA, service oriented architecture, right? And the third one is the grid, that we see, the grid computing. So the next that we are going to see is the utility computing. Okay. So utility computing is based on pay-per-use model. Resources are allowed to use on demand as a metered service. For example, that we do, how much we use, that much we pay for, right? Electricity utility, water utility, gas, and so on, right? So then look at these examples and look at these technologies. So our cloud actually is a combination of all these technologies that we have seen. Okay. So virtualization plays a role there, major role, key component, key technology behind cloud computing. And then service-oriented architecture, okay. Then grid, and also the utility computing. So all these four technologies that we have seen. So cloud computing architecture, let's look at cloud computing architecture. Cloud computing architecture comprises of many cloud components which are loosely coupled, that is not dependent to each other. That is not dependent to each other. Tightly coupled, on another words, is dependent to each other. So if something happened with one component, other component, it also affects the other component, but loosely coupled, not dependent to each other. Application platform, which is, for example, storage infrastructure. So here we can broadly divide the cloud computing architecture into two parts: the front end and the back end. The front end, actually, you see that this is related to the user, the user. And then the back end is actually where our server, databases, our storage are. So, so this is the system. It's the system architecture, and this is the block diagram that we can see. Okay, the front end is actually client infrastructure. Then we have cloud, the internet, and there we have application manager, services, cloud runtime, storage, infrastructure, hardware, the security, and so on. So each of the ends is connected through a network, usually the internet. Here. So the front end is actually, it refers to the client part. It actually refers to the client part of cloud computing system. Client part of cloud computing system. And consists of interfaces and applications that are required to access the cloud computing platforms. For example, the web browser. Okay, so using the web browser, actually, we get access to the applications that we would like to use or access. Backend is actually cloud itself. and it consists of all the resources required to provide cloud computing services. For example, data storage, virtual machines, security mechanism, services, deployment models, servers, storages, yeah, we talked about, network, so on. So backend provides inbuilt security mechanism, traffic controls, and protocols. The server employs certain protocols known as middleware, where the middleware actually help the connected devices to communicate with each other. So cloud computing distributes the file system that spreads over multiple hard disks and machines. So it means that your file is actually stored in not only in one machine, okay, multiple machines. So if something goes wrong with one machine, the other will take care. Or maybe it also depends on the on the locations. For example, uh, let's say that you have two different offices, one in this region, another one in North America or South America. So then your office in South America, if they need to get access your data from this region, you can imagine the time, the latency. So you can choose actually where you want to store. So let's say that in such case, actually you store this region as one of the stored area. The other one would be your South America, for example, you're nearby, so that you can uh, reduce the time, the latency to get access to your data. So data is never stored in one place only.
স্যার,
Yes.
তাহলে মাঝে মধ্যে যে ডেটা ব্রিচ হয়, ডেটা ব্রিচ হওয়ার ফলে আমাদের অনেক ডেটাগুলো নষ্ট হয়ে যায়, মাঝে মধ্যে আমরা রিকভার করতে পারি ব্যাকআপ সার্ভার থেকে, তাই তো?
Yes, all the time actually there are sync হয়।
তো স্যার, যদি ডেটা ব্রিচ হয়ে আমার সার্ভারে ম্যালওয়্যার প্রবেশ করে, সেটা সিঙ্ক করে সেম ম্যালওয়্যার তো অন্য সার্ভারগুলোতেও চলে যাবার কথা।
Well, that depends on how they are handling the situation. There is a chance, as you mentioned, yes, there is a chance, but then also that depends on how their security system is.
জি স্যার।
Yeah, but the concept is that, take note of this, data is never stored in one place only. Okay, I think this is a big yeah, I mean, this is the important note actually. So in case one unit fails, the other will take over automatically. So another important component is algorithm for resource allocation. Algorithm for resource allocation. So cloud computing is a strong distributed environment, and it heavily depends upon strong algorithms. So cloud computing infrastructure it consists of servers, storage device, network, cloud management, software deployment, software and platform virtualization. There are components like management software, which help to maintain and configure the infrastructure. So let's say that you subscribe some cloud providers service, then basically you get a management software where through which usually it's a management console, or it's a web browsing system. So web browser, through web browser actually you get access there, where you can maintain and configure your infrastructure. Deployment software, it helps to deploy and integrate the application on the cloud. So remember that we said that, okay, you can develop your application and then you can deploy, right? We talked about platform as a service model, right? Where you can deploy, you are given an environment to develop your applications. So once you develop your application, you can deploy. So basically you need some software or kind of interface where you can do that. So it's there. Hypervisor, another very important component, especially this component falls under virtualization. Hypervisor, actually, it's a firmware or low-level program, actually, which can interact. Low-level programming means which can interact with the hardware, right? That acts as a virtual machine manager. So hypervisor, actually, it's a virtual machine manager, and it's a firmware or a low-level program. It allows to share
Sir, you are not audible.
hello.
Yes, sir, we can hear you
Yeah,
now.
okay. So it allows to share the single physical instance of cloud resources between several tenants or several users, subscribers. Network, it is the key component of cloud infrastructure. So it allows to connect cloud services over the internet. I mean, it's a very, very important component. You got high-end resources inside your cloud data center, but you don't have a good network to support that, no point. Server helps to compute the resource sharing and offers other services such as resource allocation, deallocation, monitoring the resources, providing security, etc. Storage, cloud keeps multiple replicas of a storage. So if one of the storage resources fails, then it can be extracted from another one. And remember that we said multiple location, right? In multiple locations. Now moving to some three services, big service providers. AWS, which is provided by Amazon. Okay. GCP, provided by Google, right? And then
Microsoft Azure.
Azure is by
Microsoft.
Microsoft, right? Microsoft, right? Okay, so let's look at them. So the cloud computing infrastructure at Amazon, Google, Microsoft. So Google earlier, in early days, actually Google's effort was, I mean, this is quite long, taken from book, is that Google's effort are focused on software as a service and platform as a service, whereas Microsoft is platform as a service. Amazon is infrastructure as a service. That's where their focus was. Private clouds are an alternative to the public clouds as well that we have seen. There are some open source cloud computing platform also exist, such as Eucalyptus, Open Nebula, Nimbus, OpenStack, which can be used as a control infrastructure for a private cloud. So these are some of the open source cloud service provider.
Sir, which provider provides services of private clouds?
Well, these days, in fact, all of them are providing. All of them are providing, but depending on your needs, actually, I guess these days, I mean, I talked to some industry guy in the country, in our country. Most of our industry, actually, they choose Amazon, AWS in our country, because they find service very good, as well as the price is better. AWS is the most popular in our country. And in fact, you can see that that's how the market share is the top, right? Remember that last time
Yes, sir.
we saw that their market share is around
The
30,
highest market share.
the highest market share, right? So they are the giant in this business. So AWS, I think we still have some time, right? Let's go for another 5 minutes. Amazon, AWS. AWS is Amazon's cloud web hosting platform. That is a cloud computing platform that offers flexible, reliable, scalable, easy to use, and cost-effective solutions. See the logo that I put here. AWS can be considered as a virtual data center. The virtual data center. The AWS service uses distributed IT infrastructure to provide different IT resources available on demand. You see, even although the data that I showed quite early data, but this is the recent one, that even these days, actually, they are providing all the services. SaaS plus us, software as a service, platform as a service, and infrastructure as a service. Although this was their focus in early days. So here, one model they use or they adopt is pay as you go, pay as you go, pay as you go, which is based on the concept of pay as you go. AWS provides the services to the customers. AWS provides services to customers when required without any prior commitment or upfront investment. You don't need to make any commitment early time. Okay, I'm going to use this amount for next 1 year or 2 year and so on. Pay as you go model. Okay, now I can use this amount of storage, so I pay for this. Next month, my storage increase, I pay more. My storage further increase the next month. So pay as you go model. So AWS provides services to customers when required without any prior commitment or upfront investment. Pay as you go enables the customers to procure services from AWS, such as computing services, programming model, database, storage, networking, and so on. Almost everything that you would like to have to replace. This is the evolution of started, with 2003, the design, the implemented or launched AWS is 2006. 2006 they launched, and then the revenue is the highest one. They introduced AI, machine learning concept also with that. Even they have the certification as well. So these are, I'm not going through in detail today. I mean, you can have a look on the history of AWS. Sometimes history is good to know. Okay, so launching is 2006, but then eventually you see that how or what are the new technologies they have.
Sir, do we also
there.
need to memorize all of this history for our exam?
Well,
It would be quite difficult.
you know why it's difficult. Why is that difficult?
Sir, too much data.
Too much data. You will need more and more data to remember. You know, I mean, later on you'll see. When you work in the industry, you know, you become big boss. You know, your boss and your top boss ask you, okay, what is the current status? Then you have to memorize all of the data, and then you got just 1 minute to inform him, for example. It's not, I mean, compared to that one, it's not that difficult. I mean, not everything that you need to know, you know, these days, but at least key, you know, some of the key points or some of the key data that you need to. What is the time actually?
Sir, 11:25 a.m.
Okay, somebody got I mean classes, right?
Yes, sir. We have exam.
Sorry, what?
We have class test now. I mean, from 11:30.
All right, so then I think I have to take the
Sir, you haven't uploaded the second slide to the LMS yet now.
this one. I mean the one that I'm covering now, right?
Yes, sir. Yes, sir.
Of course, I will do that. I shall do that right after the class. You can. I think we are moving a bit slow. And also we lost some weeks, right? There were holiday. Okay.
Sir, you also haven't uploaded the attendance of our first class.
What?
স্যার আমাদের প্রথম ক্লাসে অ্যাটেন্ডেন্সটা আপডেটেড করা হয়নি, লাস্ট ক্লাসে সেকেন্ড আর থার্ড ক্লাসে অ্যাটেন্ডেন্স আপডেট করেছিলাম।
Because of UCAM problem, huh?
Yes, sir. Yes, sir.
UCAM এ যে data নিচ্ছিল না।
জি স্যার।
Okay. So we have Bahrul today.
Yes, sir.
Alif, are you there? No. Imtiaz,
Present, sir.
Saurabh,
जी सर, Saurabh present sir.
Sudipto,
Yes, sir.
Fariha,
Yes, sir.
Maruf,
Yes, sir.
Email,
Present, sir.
Amar,
Present, sir.
Tasnim,
Sir.
Raihan,
Yes, sir.
Khoshnur,
Yes, sir.
Himel,
Yes, sir.
Shojib Ahmed, Enamul Hassan,
Present, sir.
Alamin,
Present, sir.
Alamin,
Present, sir.
Amit,
Yes, sir.
Nusrat,
Present, sir.
Samiul,
Yes, sir.
Aisha, Rafia,
Yes, sir.
Rafia,
Present, sir.
Moinul,
Yes, sir.
Mehdi,
Yes, sir.
Majid,
Yes, sir.
Riyad,
Mazid, আছে।
Riyad, Sanjida,
Present, sir.
Rifa,
Yes, sir.
Samia,
Yes, sir.
Tasnim,
Yes, sir.
Usha,
Present, sir.
Arman,
Present, sir.
জান্নাতারা,
Yes, sir.
শহীদ,
Present, sir.
রবিউল, সৌরভ মন্ডল,
Yes, sir.
মহিউদ্দিন,
Rubiul, sir.
রবিউল আছে, সৌরভ আছো? সৌরভ মন্ডল নাই, মহিউদ্দিন,
স্যার চ্যাটে লিখে দিয়েছে, আচ্ছা।
মহিউদ্দিন আছে না? ওকে,
জি, স্যার।
রশিদুল, আঞ্জুমানা,
Yes, sir.
রেজানুর,
Yes,
রেজওয়ানুর,
sir.
সৃজা,
Yes, sir.
জয়শ্রী,
স্যার
Chat.
চ্যাটে লিখে দিয়েছে।
ওকে, শিহাব,
Present, sir.
আবরার,
Yes, sir.
সাইফুল,
Yes, sir.
সাইদুল,
Yes, sir.
সুপ্তি,
Yes, sir.
আব্দুল্লাহ,
Yes, sir.
ইশরাত,
Present, sir.
ফাহিম।
ইয়েস স্যার।
আচ্ছা, মিস গিয়েছো কেউ? ঠিক আছে, আজকেও কি আপডেট হবে না নাকি? হয়েছে মনে হয় না? আচ্ছা, আমরা ওই প্রথম দিনটা, তোমাদের তো আবার ক্লাস টেস্ট আছে না অন্য ক্লাসে?
স্যার
জি,
তারপর
স্যার।
নিয়ে নিতে পারবেন, কিছু সময় আছে, 2-3 মিনিটের মধ্যে হয়ে যাবে।
প্রথম দিনেরটা একটু আপডেট করে ফেলি আমরা। হোপ যে এলএমএস ঠিক হয়েছে। আরে সরি, ইউ ক্যান। আর প্রথম দিন কি বাহরুল ছিলে?
Yes, sir.
আলিফ নোমানি প্রথম দিন ছিলে? ছিলে না। ইমতিয়াজ,
জি স্যার, ছিলাম।
সৌরভ ছিলে? ফার্স্ট ক্লাসে সৌরভ ছিলে? ফার্স্ট ক্লাসে ছিলে তুমি?
সৌরভ ভাই ছিল স্যার ফার্স্ট ক্লাসে।
সুদীপ্ত ছিলে?
Yes, sir.
কাজী ফারিহা ছিলে? ফারিহা, আর ইউ দেয়ার? আচ্ছা, মারুফ ছিলে?
জি স্যার। জি স্যার।
হিমেল,
জি স্যার ছিলাম।
আম্মার,
Yes, sir. ছিলাম।
তাসনিম,
ছিলাম।
রায়হান,
জি স্যার ছিলাম।
খসনুর, খসনুর,
স্যার ও ছিল স্যার।
আচ্ছা, হিমেল, হাসান হিমেল,
জি স্যার ছিলাম স্যার।
সজীব আহমেদ,
সজীব ছিল স্যার।
এনামুল,
Yes, sir. ছিলাম।
আলামিন,
স্যার।
অমিত কুমার,
Yes, sir. ছিলাম।
নুসরাত, নুসরাত জাহান,
স্যার ছিলাম, নুসরাত জাহান।
সামিউল,
জি স্যার আমি ছিলাম।
আয়েশা, রাফিয়া, রাফিয়া, আচ্ছা, মাইনুল,
স্যার ছিলাম।
মেহেদি,
জি স্যার ছিলাম।
লুৎফুল্লাহ,
জি স্যার ছিলাম।
রিয়াদ,
রিয়াদ ছিল স্যার। ছিল স্যার।
সঞ্জিদা,
জি স্যার ছিলাম।
রিফা,
ইয়েস স্যার ছিলাম।
সামিয়া,
ইয়েস স্যার ছিলাম।
তাসনিম, তাসনিম,
তাসনিম ছিল।
উষা,
জি স্যার ছিলাম আমি।
আরমান, আরমান, জান্নাতারা, অরিত্রী ছিলে?
জি স্যার।
শাহিদ,
স্যার ছিলাম স্যার।
রবিউল,
স্যার ছিলাম।
সৌরভ, সৌরভ, মহিউদ্দিন, মহিউদ্দিন কি ছিলে? আচ্ছা, রশিদুল, রশিদুল, আঞ্জুমানা, হ্যালো আঞ্জুমানা, আমার কথা শোনা যাচ্ছে?
জি স্যার।
আঞ্জুমানা, হৃদয়, শ্রেজা,
জি স্যার প্রেজেন্ট ছিলাম।
জয়শ্রী,
স্যার ও ছিল স্যার, আপনাকে মেইলও করছি।
শিহাব,
ছিলাম স্যার।
আবরার,
জি স্যার ছিলাম।
সাইফুল,
জি স্যার।
সাইদুল,
জি স্যার ছিলাম।
চুক্তি,
সুপ্তি ছিল স্যার।
আব্দুল্লাহ,
জি স্যার ছিলাম।
ইশরাত,
জি স্যার ছিলাম।
ফাহিম।
জি স্যার ছিলাম।
আচ্ছা, ঠিক আছে। ওকে, তাহলে ভালো থাকো সবাই, সুস্থ
স্যার
থাকো।
আসসালামু আলাইকুম।
ওয়ালাইকুম সালাম। সুস্থ থাকো, সাবধানে থাকো,
জি স্যার আপনিও।
ইনশাআল্লাহ। আল্লাহ হাফেজ।
আসসালামু আলাইকুম।
ওয়ালাইকুম সালাম।